This is AQA GCSE Chemistry. It's a dual award topic within the chemical calculations section, and in this we're going to look at calculations involving concentrations. I'm going to recommend you have a go at each activity as you go through, and then you get to measure your own progress. So we are going to consider concentration both in terms of grams per decimetre cubed and moles per decimetre cubed. And we've got the triangle down here for mass in grams is concentration in grams per decimetre cubed multiplied by volume in decimetres cubed. So have a go at rearranging so that we can calculate M, C and V. And M is C times V, we can see from the triangle. And C is M over V, and V is M divided by C. We've also got to consider some of the key words. It's really important that we remember what we're talking about here. So have a think about these questions. And what you're hopefully remembering is that the solute dissolves in the solvent. So in salt water, salt is the solute, water is the solvent, and salt water is the solution. So the solute is the thing that's dissolved, the solvent is what it gets dissolved in, and the solution is where you have something dissolved in that liquid. And if I want to convert my decimetres cubed to centimetres cubed, I'd multiply by 1,000. So 1 decimetre cubed is 1,000 cm cubed, and 15 decimetre cubed is 15,000 centimetres cubed. Couple of worked examples here for some calculations. We've seen the triangle, and we're going to have a go at using that to do these examples. So I've put the triangle down there to help you again, but have a go at each of these questions and see how you do. So in the first one, we're calculating concentrations. That's M divided by V. What you will notice is I've converted my volume from cm cubed to dm cubed. I've divided by 1,000. And that's because concentration is in grams per decimetre cubed. You're going to see that that happens in every single example. I must convert my volume to decimetres cubed. On that one, I get 160 grams per decimetre cubed. On this one, 10 divided by, not 100, but 100 over 1,000. That gives me 100 grams per decimetre cubed. And I carry on through the remainder, as you can see here. So number 3, 200 grams per decimetre cubed. Number 4, 20 grams per decimetre cubed. Moving on to look at numbers 5 through to 8, and on these we are calculating the mass of the solution. Well, in this case, M is C times V. I take my concentration and I multiply by volume. Sorry, I take my concentration, 100, and I multiply by volume, 500 over 1,000. Means that I've got 50 grams dissolved in there. I do the same again here, remembering, I know I keep pointing it out, but I'm converting my centimetres cubed to decimetres cubed. I'm dividing by 1,000 each time. Half a gram in number 6, 2.5 grams for number 7, and 25 grams for number 8. Now, there is a really important distinction to make here, because we're also going to look at some examples where instead of concentration is in grams per decimetre cubed, it's in moles per decimetre cubed. But there's a really easy conversion between them. Because if I know, for example, the mass of sodium hydroxide, 40 grams of sodium hydroxide, and I know its MR, sodium 23, oxygen 16, hydrogen 1, sodium hydroxide has an MR of 40. So 40 divided by 40 means I've got 1 mole of sodium hydroxide in 1 decimetre cubed of water. So my concentration is 40 grams per decimetre cubed, but it's also 1 mole per decimetre cubed. The alternative triangle, and actually the more common triangle that you're going to see, is moles is concentration times volume. And in this case, concentration is in moles per decimetre cubed. How do we do the conversion? Well, N is CV, C is N over V, and V is N over C. So now let's have a go at some of the more straightforward mole calculations here. Try them out and we will take a look at the answers. So on number 1, I've got my N, 4, and I've got my V, 3. To get my concentration, I do 4 divided by 3, 1.33 moles per decimetre cubed. So that's already in decimetres cubed. On the next one, my 1,000 centimetre cubed, I'm converting to decimetre cubed. 1,000 over 1,000 is 1. That means I've got a concentration here of 10 moles per decimetre cubed. On to the next one, I've got 1.7 moles and my volume is 500, so I'm converting it, dividing by 1,000 to get decimetres cubed. 1.7 over 0.5 gives me 3.4 moles per decimetre cubed. And number 4, following a similar pattern but only 50 cm cubed here, 1 divided by 50 over 1,000 gives me 20 moles per decimetre cubed. And then for number 5, we move on to calculating how many moles. So N is C times V. Well, in this case, I've got my concentration, once again, in decimetres cubed, 0.5, multiplied by 7.3, I get 3.65 moles per, 3.65 moles, because it's N that we're calculating. On to number 6, and I have got 16.2. This time my volume has been given in centimetres cubed, so I'm converting it again to decimetres cubed. It takes me to 0.162 moles. For number 7, I'm working out moles again. 9.8 multiplied by my volume converted into decimetres cubed, 2.45 moles. And on the final one, we're calculating volume. So volume is N over C. N is 7. C is 6.44 moles per decimetre cubed. That means I've got 1.087 decimetres cubed, which I can convert to centimetres cubed, 1087. That takes us to the end of this video. Thank you for listening and goodbye.